morning. Sorry, I've got a slow connection going this morning. How's everybody doing today?
Good. How are you?
Good, thank you. Anything great and exciting going on this week? Anything horrible and terrible? Just a week. How was the ball game, Tyler?
It was great.
Awesome. Did I see that y'all won?
Yes, ma'am.
Very good. Congratulations. That's
Thank you.
exciting. Good start to the season. Very good. Very good. All right. So let's see. 1, 2, 3, 4, 5. Looks like we are missing Clara Jane and April and who else? Easton. I don't think anybody was going to be out today. So anyway, what we'll do is we'll go ahead. Hold on. Hang on just a second. Let's see. There's Clara. Let me send Easton the code. Let's see. So invite. Send message. Well, I thought. If I could figure out the right buttons to push. Let's see. We're just going to copy our invite link.
Really?
And then I'll email it real quick.
Yeah. Go.
I think she's hiding from you. Oh man. Why is this being so difficult?
Turn off your camera. Sorry.
Seriously? Good morning.
Keep copying the link, but then it won't paste into it. It won't give me the option to paste it. Let's see. Let me just pull it up. So, all right, as y'all can go ahead and start getting your homework out. We'll get ready to check it as soon as I can get my technology issues cleared up. Sent mail. I'm looking for our geometry Zoom. There we go. Maybe this is it. Oh my goodness. So evidently my paste function isn't working there. Let me go to my phone. Okay, Wednesdays. Okay, we'll see if that'll work. Now go ahead and warn y'all, I don't know what kind of shape my brain is going to be in today. I had, over the summer, I had shoulder surgery, and I've still been having trouble with motion. Here it comes in my shoulder, so I've been going to therapy twice a week, and so that's been a lot of fun. But anyway, so yesterday I went, and now it's both of my shoulders. And so, good morning. So I had to get 2 steroid shots yesterday in my shoulders. They didn't tell me that, like, you know, you get steroid shots, you're not going to sleep. So about 5:30 this morning, I kind of was able to close my eyes and slept for about an hour. So I might be a little slower on the uptake today, and I might be a little more confused. So y'all just point it out. If I say something crazy, y'all just tell me to, you know, tell me to get back with it. So anyway, I just want to go ahead and warn y'all. Hopefully it'll all be good. I feel pretty awake because I just laid there with my eyes wide open, and I thought about all kinds of things laying in the bed, because I finally went to bed at 1:30 and laid there till 5:30 before I could go to sleep. So anyway, we'll just, you know, never know. All right, so let's go ahead and get ready to check our homework. I think the only one we're missing is going to be April, and hopefully she'll join in soon. Any questions?
I have a question, yes.
Yes.
We're supposed to upload it to accuracy or effort?
Okay, remember I've said it doesn't matter. I said effort, because effort is where I'm looking for you getting it on time. Okay, so did you put forth the effort to, number one, get your homework done, and did you upload it on time? That's why I have effort, just because I want you to get points and credit for, number one, doing all your work, and also for getting it uploaded on time. So that's why I created effort, and then the accuracy tab is where I pull it from the effort. So when you upload it to effort, and I've got it in my tablet, then I can go ahead and grade it while I've got it in for effort, and then I just put the grade in accuracy. Okay,
Oh, I
so
accidentally put in accuracy.
it's okay. And so what I've been doing is when I'm pulling them to grade, I have started working on y'all's. I just haven't finished everything yet from last week. That'll be something I finish up this week. I'll be sure I'll have all your grades in for last week's homework. But anyway, so what I'm doing is, if I look and it's not in the effort tab, I'm just going to the accuracy tab and looking for it. So I'll hunt it down, and I will email you also if you missed a page, or if it's not in there. I will send you an email and let you know, hey, I'm missing this. And so, and what we'll need to do in that case, if you have to send me something separately, I don't think the system will let you upload after you've already uploaded. And so what I'll do is I'll have you either take a picture of it and text it to me, or you can take a picture of it and email it to me. And then that way I'm able just to pull it and add it to your work. Okay.
Okay,
So,
thank you.
yeah, no problem. If just as long as it's in one or the other, I mean, it's fine. I'll find it. Just make sure you get it to one or the other by class time. Okay. All righty. And like I said, I know it's a lot, especially with us kind of combining Wednesday and Thursday homeworks. I know it's a lot of pages, and obviously the easiest way to do it will be to use some kind of scanner app or something on your phone where you can take multiple pictures and turn it into one file. And then that way you're just uploading it all as one file. If you do that, I just have a simple small favor. If you wouldn't mind doing it in order, that would be fabulous. As I was going through my algebra class, there was one assignment that had like 4 or 5 pages, and they were all mixed up. So I'm running back and forth trying to figure out what page is what page and stuff like that. So if you're doing it all in one doc, if you could do it in order, that would make my life a little bit easier. I'm not going to count off if you don't, because I know it's a big difference doing it the way that we're doing it. So I'm going to be lenient, but it would help me if you did it in order. All righty, so let's go ahead and take a look at our homework. Remember, this is the time that we are going to go through things. If there is something that you did not understand, a couple of things about homework that that I would like you guys to do. So obviously, everything that we have been learning is coming straight from the textbook. Okay, so I'm even pulling it up, I'm highlighting, I'm making notes. So everything that we're discussing in class is in the textbook. So I recommend that if you have trouble and you get stuck on something, go back to the textbook first. Look through it, see if you can figure it out. If it's talking about we're dealing with angle bisectors, go back to angle bisector section. If it's talking about supplementary and complementary angles, go back to that section. And then so go through, see if you can figure it out. If you can't, and there's nobody at home that can help you, then it is perfectly fine. Shoot me a text, email me, call me, whatever you need to do. I've had a couple of students that I've worked with this week, and that is fantastic. I'm more than happy to help. I feel bad because sometimes when y'all send me messages, I may either be in another class, or I might not be home and have access to my stuff, so I have to put you off and get you to wait a little bit. But please, don't hesitate to ask. I don't want you struggling through this stuff and not knowing what's going on, okay? All righty, so let's take a look at the homework that was due. So our first was page 38 and 40. So let me get my book straight. All right, so we had pages 38 and 40, numbers 18 through 30 evens, and 38 through 48 evens. So we will start with number 38. So we did 38 through 40 all. No, that's pages 38 through 40. Like I said, give me a minute. Pages 38 through 40. Number 18 is where we're starting. Number 18. Okay, so on this we were doing midpoint. Okay, remember to find the midpoint. So y'all know I'm real big about, hey, picture this in your brain, because think about and I think probably if you've had me before, you've probably heard this 1,000,005 times, and I'm sorry for that, but I get stuck on my little things that I think help. Like when you were little and you started learning your letters and you did flashcards, and you would see a card and it had the letter A on it. What was the picture on the A card? Do you remember doing flashcards when you were little, or maybe you've seen them since that other little kids have?
Apple.
An apple. Okay, so now you hear the letter A and you think flashcard and you think apple. Okay, there is something to be said about creating a visual image in your mind to attach it to a word. Okay, so probably if we sat here and went through that whole stack of flashcards, y'all could probably tell me exactly what's on every single one of them. You know, because you drilled them, you looked at them, you said the letter, you saw the picture, said the letter, saw the picture. Doing math is exactly the same way. So when you hear midpoint formula, if you automatically try to picture that formula. And so that's why I was saying, like, if you made your own flashcards, where on one side it would say midpoint formula, on the other side you write the actual formula, where you'd have x1 plus x2 divided by 2, comma, y1, y2 divided by 2, and then parentheses, so you know that's an ordered pair. You're adding your x values together and dividing by 2. Add your y values, divide by 2. So if you start kind of picturing these things, as you come to these words later on, you're going to go, oh, that's what this is. Oh, that's what this is. And it'll be less work on your part because you're going to have immediate recall with that. Okay. So like on this one, finding the midpoint. Again, we know that we're dealing with midpoint. Also, one thing that I like about this book, and let me see if it's on the student book too, or if this is just let me close out some things here so I can open up my iPad. Share my content.
Did you do problem 20 on 38?
Yeah, once we get there, absolutely. Okay, so did it go? Here it comes. Ability. And one thing is, the way that we're doing class, is it working for you guys? Is anybody having trouble following the format as far as having things on the screen and things like that? Is that working? Please let me know if you're having any trouble so we can try to come up with another. I know that every class is doing things differently, and I know that it is, let's see, so we're on page 38. That's 44. Okay, so it doesn't look like, did I go too far? 32. Okay, no, it's there. Okay, so see how this, right next to these problems, and it says student help. Okay, that's one of the things I really like about this book, is it says student help. So it gives you a guide. Well, come on. Right there in that box that says homework help. So it says, hey, if you're having trouble with 17 through 24, go to example 1 in this section. If you're having trouble with it, 25 through 30, look at example 2. Okay, so it tells you where to refer back to in the book. I think a lot of times we forget that step when we're struggling with something. We forget to look back. Okay, but so it kind of, this gives us a guide, and that's one of the things I like about that. All right, so so number 18, J was -17 and K was 3, -3, and so your midpoint should be 1, 2. Remember, these are in parentheses. It's an ordered pair, 1, 2. Number 20. Number 20, I have P is -12, -9. Q is 2, 10. Okay, so the answer in this one is -5 is X, and then Y is 1/2. Is this the one you were asking about, Easton?
Yes, ma'am. Yes, ma'am.
Okay, so, all right, so we can even do this. Look at, if I'm adding my X values, I'm adding -12 plus 2. What is -12 plus 2?
10, -10.
-10. Now we've got to divide that by 2. What is -10 divided by 2?
-5.
So there's your X value. Okay, now we're going to add negative 9 plus 10. What's negative 9 plus 10?
1.
1. What's half of 1? We divide by 2.
No,
1.
no, no, no.
Half.
One
Or
half.
1 half.
Okay.
That's what I meant.
So yeah, so it'll just be 1 over 2. So your ordered pair is negative 5 is x and y is 1 half. Okay. Oh, I skipped number. We did evens. 18, 20, 22. My ordered pairs are 4, 4, and 4, negative 18. Add my x values that are 4 plus 4 is 8. 8 divided by 2 is 4. So x is 4. And 4 plus negative 18 is going to give me negative 14. Negative 14 divided by 2 is negative 7. So my ordered pair is 4, negative 7. 24, I'm dealing with some decimals here. So G is negative 5.5, negative 6.1. H is negative 0.5 and 9.1. So when I average my X values, I get negative 3. My Y values will be 1.5. Any questions on that one dealing with decimals?
What was the answer? Negative 24.
For number 24 was negative 3 is X and Y is 1.5. So because we were dealing with decimals, we left them in decimal answers. And so the other ones, they left it in fraction answers. So if it doesn't have a decimal in the problem, then you could just leave your answer as a fraction. But if it has decimals, you can leave it in decimal form. Okay. Any other questions on that section?
Thank you.
Sure. All right, now we've got 26 through 28 evens. So let's take a look at those. It says find the coordinates of the other endpoint of the segment. Okay, so remember, this was like example 2, where they gave us an endpoint, they gave us the midpoint, and we had to find the other endpoint. So number 26, the other endpoint would be 8, 7. For 28, my other endpoint would be negative 11, negative 13. And for number 30, my other endpoint would be 6.5, 15. Any questions on any of those? All right, we'll keep on going. So that was 18 through 30 evens. Now we're going to jump to 38 through 48 evens. So 38 through 48, again, analyzing angle bisectors. Again, one of those things that when I hear the word bisector, I want to picture a ray that is cutting an angle in half. Okay, bisector means it's going to be exactly in the middle and it's a ray. Okay, so I can picture that ray coming straight out the middle of an angle. So we have angle bisectors, and so we know that if something's cut in half, then each of them are going to have the same measure. So I know that one measure is equal to the other measure. So that's what I'm hoping as we go through these things, by learning the vocabulary, by learning these things, it's really not as big of a challenge if you know the terminology. All right, so it says ray QS is an angle bisector of angle PQR. Find the two angle measures not given in the diagram. Okay, so the first one, they have given us the measure for angle SQR, or we could also call that RQS. They said it was 22 degrees. So the measure for angle PQS, or if you wanted to call it SQP, that one's also going to be 22 degrees. Okay, they're both going to be 22 degrees. So when I add them together, the whole angle PQR is going to equal 44 degrees. And of course, I did number 37, and that was not assigned. So you're probably going, what in the world? 38, let's try that. SQR, the measure is 91 degrees. So that means that PQS will also be 91 degrees. So our total, what did I do? It's funny, my book has the wrong thing. So 91 degrees. Oh, y'all, like I said, I am slow on the uptake this morning. The whole stinking thing is 91 degrees. I was not looking at that. I'm just looking at where they wrote the number. Okay, so we can see how they've written that little arch. Let me just pull it up on here. So that little arch that they've put, that means the entire angle is 91 degrees. Okay, so to find the bisectors, I've got to divide by 2. So that's going to be 45.5 degrees. So PQS and SQR are each going to be 45.5 degrees. Sorry about that. Number 40. Again, they've told us the entire angle is 75 degrees. So all I have to do is divide 75 by 2. And I find out that PQS and RQS are each 37.5 degrees. And number 40, they told us that the whole thing is 124 degrees. So I divide by 2 and I get 62 degrees. So the measure of angle PQS and the measure of RQS are each 62 degrees. Questions on those? All righty, so then we moved on to pages 47 through 48. So let's jump a few pages. All right, so on 47 and 48, we had 8 through 36 evens. Okay. So this is identifying angle pairs, and it says to use the angle at the right. So number 8 says, are angle 5 and angle 6 a linear pair? So first of all, let's think back to what is a linear pair? What did we learn a linear pair is?
Two adjacent angles.
Good, it's 2 adjacent angles and their non-common sides are opposite rays. Okay, so adjacent angles side by side, their sides their non-common sides are opposite rays. Okay, so when we look at angle 5 and angle 6, these are not a linear pair. They are adjacent angles, but they are not opposite rays. Remember, opposite rays make a straight line. Okay.
What page are we on?
47.
Okay.
Okay. Number 10, are 5 and 8 a linear pair? These are actually vertical angles. They are not a linear pair. They are opposite from each other, so they are vertical angles. Look at number 12. Are 5 and 7 vertical angles? When we look at 5 and 7, they are not vertical. Okay. Remember, vertical has to be directly across from it, and they have to be equal angles. So any questions on 8 through 12 evens? Let's move on to 14 through 18 evens. So it says decide whether the statement is always, sometimes, or never true. So it says if the measure of angle 1 is 40 degrees, then the measure of angle 2 is 140 degrees. So let's look at that. First, we have to determine what is the relationship between angle 1 and angle 2, and those are vertical angles. And I should know by now that vertical angles are equal to each other. So if measure of angle 1 is 40 degrees, then 2 is going to be 40 degrees. If the measure of angle 2 is 140 degrees, then the measure of angle 1 would have to be 140 degrees. So this statement is never true. Vertical angles can never have different measures. Number 16, angle 1 and angle 4 are congruent. So look at angle 1 and angle 4, okay? So in this situation, like I said, the pictures are not always going to be drawn to scale. Remember, congruent means equal or the same. In this situation, it would just be a sometimes. Sometimes they could be, if the measure of the angle shifted, then they could become congruent. But as it's written now, they are not, but it could. And then 18, the measure of angle 2 is congruent to the measure of angle 1, and that is going to be always. They are vertical angles, they will be congruent, they will be equal to each other. Any questions on those? All righty.
Number 16.
Number 16? Okay, so like I said, if I were to, basically it's talking about, maybe it's easier if I just kind of draw it out real quick. Let me. So what it's saying is that when I look at angle 1 and angle 4, okay, angle 1 and angle 4 could become congruent if and only if this intersecting line shifted, okay? Now these would be congruent because they would be equal angles. What it's basically talking about is in this setup, whether it's written like this or written like this, however I want to write it, and I have 1, 2, 3, 4, 1, 2, 3, 4. In these situations, what we were talking about with angle 1 and angle 2, these always have to be the same no matter which way this is drawn because they're vertical angles. Okay, so no matter what shape my diagram is drawn in, if it's an intersecting line and I have my 4 angles drawn like this, then they're always going to be congruent, equal to each other. Okay, so but if I shifted, so if I was in this situation and my line went like this, then angle 1 and angle 4 could be congruent. It depends on how that intersecting line is drawn. Okay, so if they're side by side, they potentially could be congruent just depending on how it's drawn. In this particular picture, they are not. So that's one of the things about geometry, and that we'll be talking about more, is as we see our figures drawn. Now, if they gave specific numbers and asked if they were congruent, and it told you that 1 was this number and 4 was this measurement, then it would be like a definite or indefinite. I mean, like it would be a yes or no kind of thing. But when we're talking about just basic drawings, could it shift a little bit this way? So we kind of have to shift our thinking. And I think that's the biggest challenge to geometry coming off of algebra. Algebra was very linear. It was this, and you did this, and then you did this. It was very clear cut. So now we're having to kind of think about, well, what if I turned it this way? Or what if I did this way? Okay. So adjacent angles can be congruent, and that's what they're talking about there. Adjacent angles, angles that are side by side, are they congruent? Well, sometimes they are, but not always, okay? All righty, so now we're gonna move on to page 48. We've got 20 through 26 evens, okay? So it says use the figure at the right. And so they told us that the measure of angle 6 is 72 degrees. So what is the measure of angle 7? Well, if I add 6 and 7 together, these are supplementary. They form a straight line, so I know they equal 180. So 180 minus 72 is 108. Number 22, the measure of angle 9 is 110. So what is the measure of angle 8? Again, 9 and 8. Straight line, 180 degrees, so 180 minus 110 is 70 degrees. 24, the measure of angle 7 is 142 degrees. Then what is the measure of angle 8? 7 and 8. Make a straight line, 180 degrees. 180 minus 142 would be 38 degrees. And 26, the measure of angle 9 is 170 degrees. What is the measure of angle 6? 9 and 6. Adjacent angles. They're a linear pair, equals 180. 180 minus 70 is 10 degrees. Any questions on that one? Again, our terminology that we need to understand here is that two adjacent angles side by side form a straight line. They're a linear pair. Okay. All right, now we have 28 through 36. Number 28 says, find the values of the variables, okay? So first of all, what we have to do when we are looking at our drawings is we have to say, all right, how are these two measures related, okay? How are these, what is this depicting? So in number 28, I've got vertical angles. Now I have to remember, vertical angles are congruent. That means they are equal to each other. So I would need to set my equation to where 105 is equal to 2x minus 11. And when you solve for x, you should get 58. Any questions on 28? Okay, number 30. Again, vertical angles, they're equal to each other, so 78. Huh? Did somebody have a question? Okay, so in 30, 78 degrees is equal to 5x minus 2. Solve for x, and you should get 16. Any questions on 30? All right, 32 looks a little confusing, but again, if you think about your relationships here, I know a little bit easier if I just kind of start over with all this. Wonder. Okay, clean slate, maybe. All righty. So in 32, there's a couple of ways I could approach this problem, okay? I can see that these are vertical angles, okay? So anything that's across from each other, this and this one are vertical angles. So I could set up 2y plus 25 equals 2x minus 5. What's wrong with that? Why can't I do that? And that should be, first of all, that's supposed to be a 25. Why could I not set this up as my equation to solve?
You have two variables.
Two different variables, okay? So when I start to write that out, I should go, hey, something's not right here. So now what I've got to look at is, okay, that doesn't work. So now I know that I've got to look to see what sets up with the same variables. And I can see that these two right here have x's, okay? Or these two right here have y's. And so then I have to stop and think, what is the relationship of these two angles? Well, these two angles are going to be linear pairs. Linear pairs equal 180 degrees. So I know that if I add 2y plus 28 plus 4y plus 26 equals 180. I add my two angles together, equals 180. So now I combine like terms first. I want to start combining like terms before I start moving things. And I've got 2y plus 4y is 6y. And then 28 plus 26 will be 54 equals 180. Then I start moving things around. I'm going to subtract 54 from each side. And I'm going to grab my calculator to subtract. One 180 minus 54 is 126. So 6y equals 126. Divide by 6, divide by 6. Y equals 21. Okay, so I found the value of y. So I know y is 21. I'll come over here to do x. For x, I'm going to have 4x plus 10 plus 3x minus 5 equals 180 because I add them together to make a straight line. Straight line is 180 degrees. Combine my x values. 4x plus 3x is 7x plus 10 minus 5 will be a positive 5 equals 180. Subtract 5, subtract 5. 7x is equal to 175, and 175 divided by 5, by 7, back up, equals 25. X equals 25. All right, so it would be real easy to go, hey, I'm done, but I'm not. Okay, well, no, I am. I'm sorry, I lied. It didn't tell me to solve for the angle measurement, okay? It just says find the values of the variables. If it said tell the measure of each angle, I would then have to plug in y into each of these equations and solve for the measurement. I would have to plug in x and solve for the measurement, but it didn't tell me to do that. So always look back at your directions to make sure, don't do more work than you have to, but always make sure you've answered the question. All righty, so we did through 36.
What's the answer for 30?
Oh, my bad. Okay, so for 30, we said we found that x was 16. For 32, we just found that x is 25 and y is 21. For 34, again, I'm able to look and see my vertical angles both have an x variable. When I set those equal to each other because they are vertical angles, I would have 3x plus 20 is equal to 5x minus 50. And when you solve for x, x is 35. So if x equals 35, this is where I'm having to put in, let me get a different color. If x equals 35 in number 34, then what I'm going to have to do is now I'm going to have to say 3 times 35 plus 20. Okay? And so 3 times 35 is going to be 105. Plus 20 is 125 degrees. Okay, so this measure is 125 degrees. So if this one's 125 degrees, to find y, I'm going to say 180 minus 125, and that will be 55 degrees.
Where'd you get
So y
35?
is- Huh?
Where'd you get 35?
Okay, so like I said, these are vertical angles. So I've got 3x plus 20 is equal to 5x minus 50. I have to set up my equation with the same variables. So now I've got 3x plus 20 equals 5x minus 50 minus 5x minus 5x. I've got negative 2x plus 20 is equal to negative 50. Subtract 20, negative 2x is equal to negative 70. Oh, we lost Lucas. Divide by negative 2, divide by negative 2, x is equal to 35. Okay, so we found that x was equal to 35, so then we had to plug it into our equation. You could have plugged it into that one or that one, it doesn't matter. Okay, because since those are vertical angles, they're both going to be the same. So once you find that that one angle is 125, you subtract from 180 and found that y is going to be 55. Questions on that? Again, there's a lot to think through with these problems, okay? You've got to take information that you know and apply it to something else. All righty, so that was 34. Now look at 36. Okay, 36, a whole bunch of stuff going on. I see that I've got 7x, 2x, or 7x degrees, 2x degrees, and then y degrees, and then 56 degrees, okay? So what I want to do is, first of all, I've got to look and see what are the relationships here, and which relationships do I see that I can set up a math problem with, okay? And so what I can see is these are vertical angles. And so that means they're going to be equal to each other. So that means that 7x will equal 56. So divide by 7, x equals 8. Okay, so now I know that x equals 8. So here I can plug in and say 7 times 8 is 56. For this one here, for 2x, I can say 2 times 8 equals 16. Okay, so now if I know that this angle is 56, this angle is 16, I can add these together. 56 plus 16, it's going to give me 12, 72. So I know that the measure of these two angles together are 72 degrees. I've got a straight line here. So I know that now I can take 180 minus 72. What did I do? Hold up. Yeah, sorry, 180 minus 72. I was thinking it was 180 minus 172, and I was like, why is that coming up with such a tiny number? Whew, like I said, rough night. So was that 108? I need to check. Yeah, 108. Okay. Again, lots of things we had to do here. We had to find the relationship that we worked with, and that was vertical angles. Then we had to take what we solved for x and plug it in for the other tiny angle that was 2 times x. So we had to find that that was 16. Then we had to add the 7x and the 2x together. We had to add 56 and 16 and subtract that from 180. All right? Any questions on that? Okay, so then we jumped over to page 49, and we had 42 through 52 evens. Okay, 42 through 52 evens. So in 42, we're doing supplements. So basically, you are taking every number and subtracting from 180. That's all you're doing. Okay, so in 42, the measure of angle 2, I'm just going to read from left to right. Okay, we're doing supplementary, so we'd subtract 180 minus the number in the top box. So the first one would be 176 degrees. Then I would have 164 degrees, 132 degrees, 108 degrees, 90 degrees, 81 degrees, 60 degrees, 28 degrees, 11 degrees, and 2 degrees. Questions? All righty. Now, 44. It says angles C and D are supplementary. Supplementary, 180, okay? Automatically, every time you see that word, supplementary 180, complementary 90. Drill it. Okay, so supplementary 180 degrees. So it says the measure of angle D is 8 times the measure of angle C. All right, so let's think about this for a minute, okay? Again, they're making you use your noodle, okay? I know that we don't always want to do that. We want the quick and easy. I want the fastest and easiest way. I can just jot down a number. I don't want to show my work. I don't want to write it down. I just want to give an answer. I'm sorry, it's not going to happen that way. Okay, so we know that D is 8 times the measure of C. So in this situation, if we said that, where can I write? Here, we'll just erase all this. All right. So if we have angle C and angle D, and they said that D is 8 times the measure of C. So I want to let C equal X, okay? So that means we're going to let D equal 8X because they said it was 8 times the measure, okay? So we're going to let C be our unknown. We're going to let it be the variable, but I have to relate these two together with the same variable. So they said angle D was 8 times as big as C. So again, if we're dealing with supplementary angles, I know that if I add X plus 9X, I'm plus 8X, I'm jumping ahead. If I add the measure of C plus the measure of angle D, it's going to equal 180 degrees. So now X plus 8X is 9X. 9X equals 180 degrees. Divide by 9, and X is equal to 20 degrees. So what that means is if X is 120 degrees, if angle C is equal to 20 degrees, then that means angle D is equal to, I'm going to have to plug in X is 20 and 8 times 2 is 16, so this will be 160 degrees. Okay. Questions on that? All right, and then we get to 46 and 48, okay? Again, we are dealing with supplementary and complementary angles here in this next section. So in 46 and 48, we're doing complementary. We know those are equal to 190. So they've said A and B are complementary. So when I set this up, I know that I'm going to have 3x plus 7 plus 11x minus 1, run out of room, equals 90 degrees. So when I solve for x here, I've got 3x plus 11x is 14x plus 7 minus 1 is 6 equals 90. Subtract 6 from each side. 14x is equal to 84. Divide by 14. Whoop. Divide by 14. Make sure I did this right. 84 divided by 14 is 6. All right, so now I know that x is equal to 6. So now I've got to plug it in. And 3 times 6 minus 7. 3 times 6 is 18. 18 minus 7 is 11. So angle A equals 11. For B, I'm going to plug in 11x minus 1. We said that x is 6, so I have 11 times 6 minus 1. 11 times 6 is 66, minus 6 is 65. So, whoop, that's not right. 60. I went back up. Cancel. Let's do that. Okay, so 66 minus 6 is 60 degrees. Wait, what is wrong? 66 minus 6, I mean, good grief, I'm doing minus 1. Why am I subtracting 6? Told y'all I was going to have trouble today. Okay, so let's try this again. 66 minus 1 is 65 degrees. But that's still not working out. So what did I do wrong? I guess it would help. Let's see, 3 and 11 is 14. 7 minus 1 is 6. One, 12, 13, 14x plus 6 equals 90. 90 minus 6 is 84. Divided by 14 is 6. So 3 times 6 is 18, and 18 minus 7 is 11. Okay. And then 11 times 6 is 66, minus 1 is 65. Those are not working out. Why? What is my problem? My problem is I wrote the wrong sign when I was working the problem. Okay, so let this be kind of a lesson to you that if you get to the end and you go, hey, wait a minute, if this is supposed to be 11 and this is 65, when I add those together, 11 plus 65 is 76. That is not 90 degrees. I've done something wrong. The place I messed up was right there. I put a plus sign instead of a minus sign. Okay, so in the problem, it's supposed to be minus 7, and I made it a plus 7, so that messed up the whole thing. So let's fix that. That's a negative 7, so that means here I'm going to have, let me just get all this done. Okay, so a negative 7 minus 1 is negative 8. So now we're going to have to add 8 to each side, and 14x is equal to 98. So now I divide by 14, and x is equal to 7. Let's see how that changes things up here. So now if I have 3 times 7 minus 1, 3 times 7 is 21. Good grief, I'm still writing it wrong. That's a 7. 3 times 7 is 21 minus 7 equals 14 degrees. And 11 times 7 minus 1 is going to be 77 minus 1, which is 76. And when I add 14 and 76, that is 90. Whew. Sorry, guys. All right. The bad news is I've taken us a couple of minutes over break. So go ahead and take a 5-minute break and we'll come back and finish these up, okay? If you have questions, please feel free to ask.
Problem 30 on page 48. I have 5x equals 16, so I just divide by 5 and, or what?
Okay, so let's take a look at that. Let me go back to it. It was number 30.
Yes, ma'am.
So you would set it up to where you have 5x minus 2 equals 78. Okay, because we had to set this is equal to this because they're vertical angles. So I add 2, add
Oh,
2,
oh.
5x is equal to 80, divide by 5, divide by 5.
Equals 16.
So then 80 divided by 5 is going to be 16.
I kept the 5 with the x.
Huh?
When I divide by 5 by 80, I kept the 5x.
Oh, okay. Yeah, so if it helps when you divide, if you want to cancel them out by drawing a line through them so you know if you've used them up, then, just do what you need to do. So yeah, then x is equal to 16. I'm going to grab a straw for my drink. I'll be right back.
Miss Jennifer,
Yes.
I thought that we were supposed to do page 21 through pages 30 in our homework. Was that incorrect?
You know what I'm doing is we're doing Thursday's homework, 21 through 30. That's Wednesdays. I was forgetting that we've got to go over Wednesdays also. Sorry, I just didn't
Okay.
backtrack enough. Yeah, we'll go over that
I
next.
have all of the places
Sorry.
down, but I forgot to put Thursday.
Yep, I just looked at Thursday and didn't look at Wednesday.
Miss Jennifer,
Yes.
I just wanted to make sure this was okay. I uploaded the homework that was due Thursday to just the homework that was due today. Is that okay?
That's
Or
fine. Yeah, you can put it all on the same day.
Okay, thank you.
Mhm. Okay, so for the sake of time, we're going to finish up these. I'm going to just start calling out answers, and then if there's anything that y'all need me to work, stop me and we'll go through it. But anyway, I'll just go ahead and start reading out answers so we can try to, since we've got to back up and cover Wednesday's homework assignments too. Sorry about that. Okay, so we found that on 46, we were dealing with complementary angles. We had to set them, add them together, equal to 90. We're going to be doing the same thing on number 48. We're going to add our equations together. 3/4 x minus 13 plus 3x minus 17 equals 90 degrees. And we found that measure of angle A is going to be 11 degrees, and the measure of angle B will be 79 degrees. Any questions on that one? All right, the next two, 50 and 52, are supplementary angles. So we'll need to add our angles together and set them equal to 180. So when we add angle A to angle B and solve for x, we find that the measure of angle A is going to be 107 degrees, and the measure of angle B is 73 degrees. Any questions on that one? And then 52, the measure of angle A is 77 degrees. The measure of angle B is 103 degrees. Questions on that one? All righty. So now we're going to back up. Let's back on up from our homework that we had on Wednesday of last week. It was page 21. So we're going to scoot back a good bit. So page 20, piece of cake after what we've just been doing. Let's see where we are. Oh, that's 38. But
Miss Jennifer, could you repeat 48 and 50 one more time?
yes, hang on just a second. We need to be on page 21. All right. Okay, so 48, the measure of angle A was 11 degrees, and the measure of angle B was 79 degrees. And you said 50?
Yes, ma'am.
Measure of angle A is 107 degrees. And the measure of angle B is 73 degrees. Do you need me to work either of those?
I'm sorry, what did you say at the
Can you
last part?
It's fine. Do you need me to work those, or are you good?
I think I'm good on those. I got
Okay.
the first part right, and then I see what I did on the second part. So
Okay, very good, very good.
What was
All
number
right.
50?
What was number what?
52.
52, the measure of angle A is 77 degrees. The measure of angle B is 103 degrees. Do you need me to work it out? Or are you good?
Okay,
Okay,
I'm good.
awesome. Okay, so we're back it up to page 21. Like I said, for the sake of time, I'm going to scoot through these answers. Stop me though if you don't understand something, if you need help with anything. Okay, so on page 21, we had 23 through 30. And we did all on this, right? Not evens, just we did all. Is that right? Okay. So number 23 is 3. 24 is 3. 25 is 3. 26 is 11. 27 is 6. 28 is 14. 29 is 9. And 30 is 17. Questions on those? Okay. Turn the page, and on 22 we had 31 through 33, and then 40 through 43. So 31 through 33 say that suppose M is between L and N, use the segment addition postulate. So again, looking back at what is the segment addition postulate, and that just says if I have two segments that are side by side, I can add them together to form a bigger segment, okay? So it says find the lengths of LM. So on number 31, LM is going to be 4. Hold on, where am I? I think I've got it right here. Yeah. So on LM, we find that X is equal to 4. So, or in this problem, we find that X is equal to 4. So our measurements, LM will be 20. MN is 3. And they already gave us LN, which was 23. Okay. Any questions on 31? 32. Again, we have LM plus MN equals LN, so we set that up that way. When I add them together, and then when I add them together and solve for Y, I find that Y is equal to 13. Then I have to plug in the value of Y, and I find that LM is equal to 100 degrees. Not degrees, just 100, sorry. I find that LM is 100. MN is 43, and they already told us that LN was 143. And 33. They did not tell us any of these exact numbers, so I have to set it to where I have 1/2 z plus 2 plus 3z plus 3 over 2 equals 5z minus 2. So I've got to set it up to where LM plus MN is equal to LN, solve for z, and I find that z is equal to 1. So when I plug in 1 to my equation, I find that the measure of LM is 2.5, MN is 4.5, and so the measure of LN altogether is 7. Questions on that one?
Would you mind working this
The main thing,
problem?
I'm sorry?
Would you mind working this problem? I was a little bit confused.
Yeah. And one of the things to remember, what I was going to say is remember that when we are working with, let me erase. Remember that when we are working with fractions and we need to clear a fraction, we do that by multiplying by the denominator. Okay, so in this situation, we're going to set it up to where we have 1/2 z plus 2 plus 3z plus 3 over 2. I need to move. See what? Write it. 1/2 z plus 2 plus 3z plus 3 over 2 is equal to 5z plus 2. Okay, so first thing we always want to do is combine like terms. So I have 1/2 z plus 3z. So that's going to give me 3.5 z. Remember, when I'm adding a number and a fraction, I just write them side by side. So 3.5 z plus 2 plus 3/2 will be 2 3/2 equals 5z plus 2. Okay. So now what I'm going to do is I am going to go ahead and I want to clear these denominators. I want to get rid of my fractions. It'll make it so much easier to deal with. Okay, so the first thing I want to do is I want to go ahead and convert my mixed numbers to improper fractions. So 3.5 is going to become 7 over 2z plus 2 3/2 will become 7 over 2. And then I still have 5z plus 2. Are you good with me up to there? All I did was convert my mixed numbers to improper fractions. To do that, you multiply denominator by whole number and then add the numerator. That becomes your new numerator and you keep the denominator. So I've got 7 halves z plus 7 halves equals 5z plus 2. Remember, to eliminate the fraction, that means I want to multiply everything by the denominator. Both of these have a denominator of 2. So that means I have to multiply my entire equation by 2, left side and right side. I can't quite get my 2 written over here on the side. We'll know it's there. Okay, so that means when I multiply this by 2, that denominator goes away. When I multiply this fraction by 2, that denominator goes away. But now I have to multiply both terms over here. So when I clean that up, I've got 7z plus 7 equals 5z times 2 is 10z. 2 times 2 is 4. Now I've got it in a more workable format. I'm not as intimidated. I've got rid of my fractions. So I'm going to subtract 10z, subtract 10z. So I have negative 3z plus 7 equals 4. Subtract 7, negative 3z is equal to negative 3. Divide by negative 3, divide by negative 3. So z is equal to 1. So then when I plug in 1/2 of 1 is 1/2 plus 2 equals 2.5. 3 times 1 is 3. When I add 3 plus 3/2, I get 3 and 3/2. I'm going to go ahead and convert that 3/2. It's an improper fraction, so 3/2 becomes 1.5. So 1.5 plus the 3 that was already there becomes 4.5. And then 4.5 plus 2.5 equals 7. You good with that? A lot of times fractions will kind of throw us off, but you know what to do with them to clear the fraction. The main thing to remember is that you have to multiply every term on the left side by that number and every term on the right side by that number to keep it balanced. Okay? All righty. Now we're going 40 to 43. So jump down. We were dealing with congruent distance. So it says use the distance formula to decide whether PQ is congruent to QR. Again, distance formula. Flipping back to page 19, our distance formula tells us that the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's our distance formula. So what we're having to do is plug those values in using the distance formula and then tell, are they congruent? Okay, so number 40, we find that PQ and QR both equal the square root of 13, so they are congruent. 41, PQ and QR each equal the square root of 170, so they are congruent. 42, we find that PQ is equal to 2 times the square root of 41, and QR is equal to the square root of 173. Those are not congruent.
On 42, I pulled out a 3.
Okay, what was your prime factorization?
I had 18, and then I did 3 times 3, and then times 2, so I pulled out 3.
Hold on just a minute. So on 42, when you found PQ, what did you have as your big number before you did prime factorization?
18.
On PQ?
Yes, ma'am.
Okay, so let's take a look at that. So we know that we're going to have, first we're going to do negative 5 minus 5, or plus, negative 5 minus 5 squared plus negative 7 minus 1 squared. Okay.
Oh, I had 5 minus -5, and then 1
Yeah,
minus.
so you did reverse order. You've got to do, it's x2 minus x1, y2 minus y1. So that's where the mistake came in. Okay. So go back and rework those. Go back, if you did the wrong order, go back and rework those. Okay. And then for 43, PQ and QR both ended up equaling 2 times the square root of 85. Remember that with radicals, we need to simplify, and sometimes it just takes time figuring out, can you simplify the number? Use a calculator, okay? Now you don't want you, and I guess it's the kind of thing where if you put in the square root of 173, you know, you're gonna end up with a decimal number, but if you put it in for each of the distances, you're going to find that they're not congruent. You wouldn't find it as a simplified radical, but you would at least be able to tell if they're congruent or not. All righty, so that was 40 through 43, and then we go to page 24. 24, we had 62 through 71. Okay, so we were looking at our figure, and then we were determining if we had true or false statements. So we have a plane. We have a line that is on the plane. That's line ABC or line AC that's on the plane. Then we can see that we have line DBE that is going through the plane. Okay, so 62 says E lies on BD. And so when we look at line BD, E is on BD. So that's true. 63, E lies on ray BD. Well, if we look at ray BD, that starts at B and goes up to D, so that is false. E is not on that ray. It is on the line, but not the ray. We've got to look at our little symbols.
What's the answer
64,
for 42?
I'm sorry?
What's the answer for 42? Because I think I guys did it.
Number 62?
42 on for PQ.
I'm sorry, we had already jumped ahead. So tell me where you are again on 42. Oh, we didn't have, hold on. So 40 through 43. Okay, so 42, PQ equals 2 times the square root of 41, and QR is the square root of 173.
Yes.
All righty. Okay, so we found on 24, 62 is true, 63 is false, 64, A, B, and D are collinear. A, B, and D are not all on the same line, so that is false. 65, BD, ray BD and ray BE are opposite rays. That is true. Remember, opposite rays form a straight line. 66, B lies in plane ABC. That is true.
I need your consent on a few items.
67, the intersection of line DE and line AC is B. That is also true. Any questions on those? Moving on to the next section, name the ray that's described. It says name a ray that contains M. So if we're looking at a ray that contains M, we could either have ray PM, we could have ray NM, we could have ray QM, we could have ray MN, or ray MQ. It just says to name a ray. There were all possibilities, so you could have had one of those. You didn't have to list them all. 69 says name a ray that has N as an endpoint. So there's 2 possibilities here. You could either have ray NM, or you could have ray NQ. Remember, if it's the endpoint, it will be the first letter. Number 70, name 2 rays that intersect at P. You would have ray PM and ray PQ. 71, name a pair of opposite rays. You would have ray NM and ray NQ. Questions? All right, page 29. Do what? Did somebody ask me to repeat something?
Can you repeat number 71?
71. 71, the pair of
Yes, ma'am.
opposite rays would be ray NM and ray NQ. Okie doke. Now we are moving on to page 29, number 17 through 22. All right, 17 through 22 at the bottom of the page, it says name the vertex and sides of the angles. Okay. Number 17, my vertex is X. My sides are ray XF and ray XT. Number 18, my vertex is N and my rays are ray NK and ray NE. 19, my vertex is Q. Now this next section says write two names for the angle. So there are three possibilities here. So I could name it just angle A. I can name it by the vertex. I could name it angle EAU or angle UAE. Any of those, just choose two of those. 21, same thing. I can name it angle C, or I could name it angle BCD or angle DCB. And 22, I could name it angle T, or I could name it angle PTS or angle STP. Questions? All righty, and then finally, page 30, 26 through 28. Okay, so it says use angle addition postulate to find the measure of the unknown angle. So again, remember that the angle addition postulate tells me that all I have to do is add the two angles together to equal something. So in 26, I'm adding 45 plus 60, and that equals 105. And 27, I see that I've got a straight line, so I know immediately it should equal to 80, and 120 plus 60 is 180. Now look at 28. In red, I have my whole little angle swoop that says 160, so now I know the entire thing equals 160. I know part of it is 20, so I've got to solve for my other part, so 160 minus 20 is 140 degrees. Any questions on those? All righty. I know that's been a lot today to go over.
Are we gonna get this much homework every week?
I hope not. Right now, we're really trying to get the fundamentals down. We're trying to get, the foundational part of it to make sure, I'm trying to make sure to give you enough practice right now of these foundational things. I'm hoping that it won't be nearly this much. And hopefully it'll move quicker, especially on the weeks that we're back in the classroom and stuff like that. But anyway, we'll just go with it. But hopefully not much more than this. And I know it's hard having back-to-back school days, but just definitely don't wait till the night before to do your work. Make sure you plan out through the week on when to get your work done. All right, so now we are jumping over to page 1. It's page 51. It's 1.7. I want you to get ready to write some notes. So get a clean sheet of paper and get a pencil. And we are on page 51. Okay, so it says the introduction to perimeter, circumference, and area. Okay. So again, I know that these things are written right here, but let's just go ahead and that's not what I want. Let me just go here and let's get a new sheet of paper. We are looking at perimeter, circumference, and area formulas. Okay, so what I want you to do is perimeter. This is going to be the measure around a figure. Now I'm going to put in parentheses outside. Okay, so that's going to be the measure around it on the outside. Our area is going to be the measure of the inside of a figure. And then circumference. Sorry, I've got my bad stylus. This one doesn't write very well. Circumference is going to be the measure around a circle. Just know that perimeter and circumference are similar, but circumference is only for a circle because it's round and it doesn't have straight edge sides. Okay. So a square will have perimeter. And when we do the perimeter, we can either call it side plus side plus side plus side, or we can call it 4S. We can just do 4 times whatever the side measure is. For area, we're doing side times side, and we can call that side squared. Remember, when I have that exponent, that means I'm multiplying S by itself. I'm not doing S times 2. I'm doing side times side. Okay, so that's with our square. With our rectangle, since I have 2 sides that are different measures, or I have 2 sides that are equal to one another, but then they're different measures from the other 2 sides, I don't want to call those sides because they're not equal measures. So with these, we have length, which you'll see written as kind of that cursive L, and width, which is usually just a W. And so perimeter is equal to 2 times the length. Actually, let me do this real quick. We could either do length plus width, or the simplified version of that would be 2 times the length plus 2 times the width. Again, all you're doing is adding all the 4 sides together. For area, all we're doing is length times width. We're multiplying the 2 together. Okay, so a triangle, I want you to think about something for a minute. If this was my rectangle, what would happen if I put a little shape through there? If I cut it in half like that, notice I've formed 2 triangles, right? So that is why when our formula for a triangle, when we get to area in a minute, that is 1/2 length times width. And that's the reason for that is because length times width is a rectangle. A triangle is half of a rectangle. So that's why it's half length times width. But then perimeter will just be A plus B plus C. Because when we have a triangle, we just have 3 sides named A, B, and C. All we do is add them together. And then for our circle, we have circumference, and this is a formula that we're just going to have to memorize, which is 2 pi r, where r equals the radius of the circle. And we're going to talk about all this in a little bit. And the radius is a point in the center of a circle that connects to any point on the circle. Okay, so when we're talking about radius, you'll know my picture's not going to be perfect. I've got my dot in the center, okay? So when I'm talking about radius, I'm going any point from that dot to a point on the circle. and it can go any direction. And it doesn't matter where it's going from. If your circle is drawn to scale, if it's perfect, mine is not, then your radius will all be the same. But if I'm talking about the entire line that goes from edge to edge through the radius and through the center, that's going to be our diameter. And this is going to be a segment that touches each side of the circle through the center. Okay, so our diameter has to go through the center. It doesn't matter which way it's going, it just has to go, and it has to have 2 endpoints on the circle and go through the center. One thing to note is that the radius equals 1/2 of the diameter. Okay, so diameter would be radius plus radius, or 2 times the radius. Okay, so that is why for circumference, I can use the formula 2 pi r, or we just learned that 2 times pi is d. We can also call it pi d. So I can either have 2 pi r, or I can use pi d, since 2 times. Okay, so we can use either. Okay, they're going to give you the exact same answer. But when we're doing the area of a circle, it's going to be pi r squared. That means I'm going to have to take the radius squared and then multiply by pi. Now, the directions will tell us if they want us to use 3.14 for pi. In Horizons last year, anytime we dealt with pi, it always just told us to use it as a symbol. It never had us multiply, okay? If you're having to multiply by 3.14, this is where a calculator is going to come in super handy, all right? Any questions about any of those that we've written down so far?
Could you scroll back up to square? I think I missed one part of it.
Sure.
Okay, perfect. Thank you.
So, sure, and I'll go ahead and label each of these if it helps. I'm sure y'all already know this is, you know. All righty. So let's go ahead and take a look at example 1. Or before we do that, notice that one thing I want to tell you real quick about pi. Pi equals the ratio. What do you think about when you hear ratio? Picture, fraction. The ratio of the circle's circumference to its diameter. So every single time you are dealing with a circle, if you get the calculation of the circumference, I didn't even spell that right, circumference, divided by diameter, every single time, that's going to equal pi. Okay, so you can take the circumference, divide by diameter of a circle, and you're going to end up with the 3.14, blah, 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 when you do it on a calculator. Okay, so we'll be talking more about that in just a little bit. Underneath that green box where we pulled this from, it says the measurements of perimeter and circumference use units such as centimeters, meters, kilometers, inches, feet, yards, and miles. The measurements of area use units such as square centimeters and square meters and so on. So one of the things to know about area, okay, because when we're dealing with area, we're multiplying 2 things together. So that's why we have an answer squared. Later on, when we get to volume, we're multiplying 3 things together, so we have an answer cubed. Okay, so when we write our answers, you know, it might be 15 meters squared. All right, so just know that when we're writing our answers for perimeter, it would just be meters, kilometers, inches, whatever it is. But then if it's area, it will be that unit squared. Okay. So example 1, let me go back to this. Example 1 says finding the perimeter and area of a rectangle. So it says begin by drawing a diagram and labeling the length and width, then use the formulas for perimeter and area of a rectangle. Okay, so it says find the perimeter and area of a rectangle of a length of 12 inches and a width of 5 inches. I'm going to say, like, unless the directions told you to draw a picture first, don't draw a picture, just multiply. Okay, just set it up where you have perimeter equals 2L plus 2W, plug in 12 for your length, 5 for the width, and 2 times 12 is 24, 2 times 5 is 10, add them together and you get 34. Okay, so that's dealing with perimeter. Then with your area, 12 times 5 is 60. Okay, y'all been doing perimeter and area. I can't remember if it starts in like 4th grade, 5th grade, whatever it is. Y'all been doing this a while. I'm sure you're pretty comfortable doing that. So we're not going to spend too much time on that. Let's go ahead and flip the page to page 52. Okay, 52 is dealing with the area and circumference of a circle. So it says find the diameter, radius, and circumference, find the diameter, radius, circumference, and area of a circle shown at the right. And it says use 3.14 as an approximation for pi. So when my directions say that, I know that I'm going to plug in 3.14 to be able to find my answer. Okay. So what it has shown us is that if we use this ruler that they've shown us here, okay, when I've got my ruler set up, I can see that my measurement goes from 5 to 13. What is 5? I mean, what is 13 minus 5? That's going to be 8, right? So if I'm doing my measurement right here, that total is 8. So my diameter equals 8. If my diameter is 8, then what is my radius? Remember, radius is half the diameter, so my radius is 4. Okay? So by looking at those measures, I can see that my diameter is 8, my radius is 4. Then I can plug in my formulas where circumference equals 2 pi r. I'm going to plug in my 2 because that's part of my formula. I'm going to plug in 3.14 for pi, and I found that my radius was 4. I multiply them all together. Now, one of the things I want you to notice is we have this approximate symbol here, using an approximation. And the reason we do that is because we have approximated the number for pi. 3.8, what we use to mean it's an approximate answer. We'll do the same thing here for area. Pi r squared. We plug in our approximation for pi. We found that the radius is 4, and is going to be 16. That is not 4 times 2. It is 4 squares. So then I multiply 16 times 3.14, and I get 50.2 centimeters. And remember, this is where I'm going to put my exponent of 2 in my answer. Any questions about that? All right, example 3. And I guess we have to get ready and go. I know you're heartbroken. Let's go ahead and go to page 'll tell you what, I'll give you a break. No homework tonight. We'll just wait and get it tomorrow night, okay? Because I don't want to give you just a few problems for no reason when we're going to have class again tomorrow. So, Alec, your wish has been granted. You do not have homework tonight. All right. So I will see you guys tomorrow morning, 8:30. I hope y'all have a great afternoon. And I will see y'all tomorrow.
Bye.
Bye, guys.
Bye, Miss Jennifer.
Bye, Miss Jennifer.
Thank you.
Bye.
Thank
Bye.
you.
Bye. You're welcome. Y'all have a good afternoon.